right, welcome everybody. Where are my Spark peeps at? Spark? All right, okay. Well, other people are soon to be Spark people, so that's good. I'm Ginger Holt. I'm a tech lead in our infrastructure data science team at Databricks. And I'm here with Denny Lee. We're going to talk to you about using Spark from anywhere.
Yeah, hi everybody. My name is Denny Lee. I'm a developer advocate at Databricks, just as introduced. I'm a longtime Spark contributor, also Delta Lake maintainer, MLflow contributor. So we want this to be an interactive session, okay? So we have, we have 5 Learning Spark books to give away, okay? I don't have them with me, but we're gonna give them, you're gonna ping us. Whoever asks the best questions, we're going to give those books to them. And meanwhile, we also have Hello Dolly stickers if you guys like the LLM stuff that we're talking about on Monday. So we have stickers for you guys in the interim if you ask some decent questions, okay? Cool?
All right. And I think, I'm just noticing a really young participant here. I've got to just go give this little baby a sticker.
You got it.
So cute. All right, and again, please ask your questions throughout the talk. Again, we want this to be engaging and people to participate. So I'm going to first talk to you about the evolution of Spark. So when you think about Spark, it's very often associated with data centers and large clusters. But over time, we've built tens to hundreds of applications. We've got thousands of users of Spark, and when we say we have applications running on Spark, it's always intermingled, right? So it's never an application just running Spark separately. And the reason that is, if you zoom into the architecture of Spark, right, it's a monolithic driver. So when you're running your application logic, you're also running Spark Analyzer, Optimizer, scheduler, and a distributed execution center. So if I'm submitting a Spark job, it's not running locally. It's not running dedicated. It's just running together with this Spark monolithic driver. So it's very much intertwined. So the problem is that data applications don't just live in data centers anymore, right? So if you think about all these applications, so notebooks, IDEs, we've got web services running on application servers and these edge devices. So we've had this evolution. So initially Spark was really successful with the notebook interface, right? So you have this ability to have this interactive feedback loop. But now we have more and more mission critical workloads. So we want to design and integrate those from IDEs. We want to be able to use Spark not just within Spark as an ETL or a notebook interface, but we want to be able to call Spark from anywhere. All right, so and also what about these edge devices? So today when we connect to Spark from our laptop, from servers, so if we want to run an Internet of Things device somewhere, we still want to be able to leverage the power of the Apache Spark ecosystem because I want to do machine learning, AI, and all of this. So how do I do this? How do I embed Spark in applications? Well, there are certain challenges around the developer experience. So with this coupling with the monolithic driver, there's a lot of challenges to embed Spark within your application. So the standard solution that people come up with is just to use SQL and SQL strings. While SQL is great, we all love SQL, doesn't capture the full expressiveness of Spark and makes use cases such as machine learning really, really hard or virtually impossible. So some applications like notebooks, when you use Spark in notebooks, it has their own protocol. You basically send over snippets of code using strings. And this is very cumbersome and also difficult to debug. And so for some programming language, you don't even have a JVM interop. So it's difficult to leverage Spark at all in those cases. All right, and so let's talk about, even for the applications that you can use Spark, you have multi-tenancy operational issues. So I've listed 5 here. And fundamentally, the problem here is a lack of isolation. So one application using too much memory might kill the other applications in the same driver. So you get that issue. Dependency conflicts really are the norm. Because one example here is because they had two dependencies, Spark had been packaging for a very long time a very ancient version of Guava. So this is the kind of challenge we see because now all of these dependencies in Spark become intermingled within your application. So you have to figure out how to shape the applications properly. And all of these dependencies are in constant conflict. So let's talk about upgradability. So Spark is upgrading. You try to upgrade. What do you need to change? And it's difficult to upgrade Spark because you have to upgrade the application at the same time. And debuggability. So debuggability is oftentimes difficult because you may not have the right security permission to attach to the process. So how do you step through debugging from your IDE? How do you decouple the errors of your client application from the errors of Spark? Let's see, and similar challenges with observability. So let's talk about Spark Connect, which is a solution built by the Spark Connect team. So they needed to figure out how to build an interface that allows us to basically service all of these client applications in the same way and at the same time still leverage the full power of the Apache Spark ecosystem. So what is Spark Connect? So Spark Connect introduces a decoupled client-server architecture that enables remote connectivity to Spark clusters from any application running anywhere. And so this separation of client and servers allows modern data applications, IDEs, notebooks, and programming languages to access Spark interactively. And so it's a client API, which is designed to be very thin. So you can embed it anywhere from application servers, IDEs, notebooks, and all programming languages here. And from this aspect, it's very similar to JDBC, ODBC, and various SQL drivers, but it does a lot more than SQL because you can get the full power of Spark with the data frame API. So let's talk about that. So when they were designing Spark Connect, really the kind of the essence that it's built on is this data frame API. So it's the most powerful, most used interface of Spark. And the common denominator of the data frame API is that it expresses the intent of what we want to do. So if you look at this example here, where we're basically taking this intent and translating it into a common representation, which is a logical plan. So it's basically one level higher than the logical plan of the Catalyst Optimizer, for example. And so if you look at this snippet here, we're in Spark, we're reading a table, we're selecting, we're extracting, and then we're writing, right? So that's translated into a logical parse plan. And then we can, at that high level, then we can just send it out to the server via gRPC or protobuf, and then results are streamed back to the client via gRPC or Arrow.
Sorry, I'm just going to chime in real quick, if that's okay. So for everybody looking at this diagram, I mean, it's a little small, so I apologize, but the context here is this, okay? When we're talking about the client, it's actually protobuf, okay? So all of you guys are familiar with protobuf, yes? Right, okay, cool. So we're actually utilizing protobuf properly within the Spark context, okay? This is something we haven't done in ages. We've actually been fighting it for the longest time, and so we actually are doing this now. The other key thing is that when we're sending information back from the server to the client, we actually are using Arrow. How many of you are using Arrow here? No? Okay. Seriously, you gotta start checking that out, okay? For many distributed systems, many other systems in general, we're actually starting to use Arrow basically as the in-memory format for interchange, okay, for all these systems. This isn't just restricted to like the Spark ecosystem. I'm talking about Scala ecosystem wide, as well as into other systems like the Rust and Python ecosystems. We're basically using Arrow as the interchange. Now, right now, honestly, Arrow is updating at about once every 2 weeks, okay? So don't go ahead and try to keep up with it. The way I figure Arrow 1.0 will come out, I'd say in about 6 to 9 months, okay? Because of all the updates that's happening over there. But the point is that it is becoming a very standard interchange for in-memory interchange for a lot of systems in general now. And so having us, as in Scala developers here, okay, actually start utilizing Arrow as a way to interchange allows us to be compatible with the rest of the, with all the other data communities, whether you're talking about Go, Rust, Python, or any other Scala-based ecosystem. So I did want to call that out, okay? Cool. If you have any questions, keep on doing them. Otherwise, we'll just keep on going here. Sorry.
We haven't had a question. Surely there's a question. Yes. I'll go get him a sticker.
Oh, sure. Good.
Thank you. So I notice in this diagram, it seems you're sending the unresolved logical plan up to the server. So one of my frustrations with Databricks Connect, not the same as Spark Connect, right, but a former solution, was that we couldn't use user-defined functions. I'm curious if there will be
I'm going to interrupt you right now because Databricks Connect, you're talking about V1, okay?
Okay.
No. It's fair. No. In other words, I'm going to agree with you fully. This is being recorded, right? So I have to be a little bit more gentle with my responses, okay? So it was a suboptimal process. So if this wasn't being recorded, I would probably give you a much more verbose answer. So the context basically is, you're right. I'm actually going to show you Databricks Databricks Connect V2, excuse me, okay? Which should resolve most of your problems because long story short, Databricks Connect V2 leverages Spark Connect. So we can, this is the new architecture we have to make it easier for us to work with IDEs and everything else. And so when it comes to functions like that, we should have most of the issues resolved. I'm jumping a little ahead into the session, but the quick answer also to note the fact that it does not currently support RDDs. So we are expecting everybody to work on the data frames or data set APIs in order for it to work. Okay?
Is that V2 is GA, right?
Depending on which environment. Oh. Yeah, sorry. She was asking, is Databricks Connect V2 GA? I'm going, depending on which environment it's on, it's GA, and I don't remember which one, so I don't want to answer that right now. Sorry. Any other questions before we continue? No? Okay, but keep them coming. Keep them going. Yeah.
Okay. Yeah. All right. So basically, with Spark Connect, you get the power of Apache Spark everywhere with a thin client. We can use it from all of these applications that we talked about earlier. So in summary, with a stable client-server protocol and thin client, Spark Connect opens up the possibility to embed the power of Spark everywhere. The thin client can run in devices with very limited compute power and leverage the backend Spark cluster in the cloud for heavy lifting. So let's talk about these multi-tenant operational issues that we had before Spark Connect. So now when I get out of memory errors, which I'll still get if I'm trying to load too much data, but it's going to be locally in the thin client, right? It's not going to kill the Spark driver. So that issue is mitigated. With dependency conflicts, so dependencies are isolated for each application in their client. Upgradability, you can now upgrade everything independently for performance and security patches, so you can upgrade as needed. It's not, we don't have this dependency and intermingledness of having to upgrade everything at the same time. Debuggability, you can step through debugging in the client just like any other application. And then with observability, you can have logging and metrics in the thin client just like any other application. Any questions about these these issues.
I'm just curious, has anybody who's been playing with Spark ever actually had to, for example, when it comes to dependencies, actually had to upgrade Spark before? Go for it. Okay. All right. Tell me your experience.
And so forth. So it's always a constant battle to try to keep ahead.
Right. So, for example, you mentioned the Log4j one because that was a fun event for all of us, right? That was enjoyable. I'm being very facetious, by the way. Are y'all? I'm presuming, since we're all Scala developers here, or most of us here, you've shaded stuff, right? Yeah. Right. Okay. So, have you ever seen the amount of shading we have to do in Spark for things to work? For example, do you know what version of Jackson we're using? Okay. Or no, actually, better one. Do you know what version of Java we're using right now to build? Does anybody happen to know what version of Java we're using to build Spark? 8. That's right, 8. Okay. How many of y'all like Java 8? No, come on. That was a trick question. Come on, man. We can barely handle Java 11, let alone 8. Yeah. So incidentally, by the way, there's a thread going on the Spark thread right now where we're going like, can we just kill 8? I'm like, yeah. And then now people are chiming in. It's like, no, let's just go to 17 and 20. We're like, yeah, actually, we'd like that. But so I'm saying that we actually have all of these dependencies that at least the client doesn't actually have to deal with anymore. So you can be a whatever version with the client, and then we can eventually, for example, upgrade Spark to Java 20 or Java 17. Don't try that right now. There are issues. Okay, but the idea is that we can go start doing things like that.
So
yeah.
So when we upgraded from like 2.11 to 2.12, 2.13 or whatever.
Right.
Yeah, it was 2.12. So we basically just had to rebuild the whole data center, but we took advantage of containerizing it, containerizing the driver and the rest in the process. But then, so you mean that's a lot of work, obviously, because you have to basically, redo everything from the ground up and get it all kind of working, and then you could transfer from the one application to the other application. So
that's right.
It's really tough. And then I've had some problems where I could not shade, I could not get something to work at all. Period.
Yeah. For example, if you look at our SPT version, we're still using, I want to say 0.13, for example, which that's the latest version, right? How many of you? Actually, I'm just curious from a Scala version. Who's on Scala 3 right now? Okay, perfect. Thank you. Who's on Scala 2.13? All right, perfect. Who's on Scala 2.12? Okay, and 2.11? Oh, thank God. Okay. All right, good. So we just upgraded Spark 3. We're 3.4 right now. We G 3.4. I'm sorry, I'm already working on the 3.5 tree, so I don't remember what build I'm on right now. But okay, with the 3.4 tree, we just standardized in Scala 2.12. And that's our default. We can actually build on Scala 2.13. Don't try on Scala 3 yet. Still got to fix that. But the context is that obviously, as you know, in this ecosystem, unless you're going super fast, trying to upgrade all these things can be tricky. And that's more or less the context, the separation of the server, Spark server itself, okay, versus the client. So that way you can separate how you're running your client and how you build your clients from what your server infrastructure. So like he called out in terms of whether his system, his data center was actually still working in, let's just say 2.11 for sake of argument. It didn't matter what the client version was any longer. They could still interact with each other because what are we doing? We're interacting by sending protobuf and we're receiving by arrow. Now, obviously I don't want you to go back to 2.11, that'd be silly, but the context I'm trying to get at is that this is a long-standing problem that even though Spark was known for it being part of the big data infrastructure, Spark itself was, the primary driver was a monolith, right? And so it took us a while, but now we're here and we're finally breaking that apart, where the driver itself is no longer a monolith. And that's been driving us, at least everybody in the Spark community, be a little bit nicer, a little crazier than we should have been. So fortunately, we're actually able to do that now. So we're pretty happy about that. That's why we're really excited about this, because this hopefully will make it easier for everybody who's using the Spark ecosystem to actually build cooler clients and not necessarily need to worry about what the driver, or what the primary driver is behind the scenes. Okay, cool. Any other questions before we go on?
I think you're up.
Oh, it's my turn? Oh, sorry. Cool. All right. Okay, so this is demo time. But before I went to demo time, I did want to go ahead and actually call out something here that was sort of funny. So there we go. Haha. I'm wondering, by any chance, are you familiar with this particular blog? Apache Spark 2.0, re-architecting Spark for mobile platforms. No? Okay. All right.
15.
So no. Okay. So this is the screenshot that we created. Okay. Now, if you can't tell, I will zoom in just for this purpose. This was written by Reynolds, and notice the date. Okay. So that was our April Fool's joke. Okay. All right. Back in 2015, we're going to go ahead and run Spark on mobile. Okay. Here's the funny thing. We can technically do that now. Now, it took us 8 years, but we actually can technically do that now. Now, obviously, you're not going to run the Spark driver on your iPhone. That would seem silly now, wouldn't it? Now, it'd be also fun, because I would then try to go ahead and have actually multiple Spark workers on multiple iPhones just for giggles, but that's probably not the primary use case for this project, okay? But you can presumably actually go ahead and run the client, though, directly on it. Now, obviously, we haven't built one yet. I was actually seeing if we can build one for Data and AI Summit at the end of the month. I might still be able to pull it off, but I don't know at the time. But the context is, now that the client is separated from the driver itself, you can actually achieve what Reynolds said 8 years ago as an April Fool's joke. Okay, so now, obviously, this is not the real reason we built this. I mean, as Ginger called out, the real reason built is because there's a lot of, come on, we're all building these data engineering or complex computer systems. How many times have you run into out of memory errors? Right. No, really, you all should be raising your hands. Anything that remotely is performant, it's going to go ahead and hit some form of oops. You've at least hit GCs, yes? Yeah. Come on, everybody, you got to raise your hands again, right? You've got to been hitting GCs, okay? So how many of you also, when you're using Scala, Spark, Kotlin, or whatever system you're doing, decide that you're going to use Notebook as your production system? No, you're not. I'm joking. No, well, you can realistically do that from a debuggability perspective, from a process perspective. You're obviously not going to do that, okay? As much as even I was pitching the idea, ooh, let's use notebooks. I mean, those are fun, but am I going to build a production system like that? Nah, I'm not going to do that. Okay, so it's what Ginger called out. We have all these problems with the system, okay? It's tied to the simple fact that our one Spark driver did everything. Okay, it did it well, it ran, but my goodness, there were problems with it. Okay, so now with Spark Connect, and it was released in 3.4. I'm going to show you a bunch of class path errors, by the way, so you'll you'll have fun with those. Basically, it's actually experimental in Scala so far with 3.4. 3.5, I think we might be able to remove the experimental. Long story short, and I'll show you in the demo. Basically, we are fighting with class paths. How many of you have been fighting with class paths? Yeah, exactly, right? So we've been fighting with class paths right now with it, so that's why it's still experimental. We actually had to put the code in a completely different location, and we actually have to build it every time we run the client. It's a little bit silly, but it'll get solved. It's using the dataset APIs. I'm just curious, does anybody know the difference between RDD, data frames, datasets? Can anybody tell me that? Go for it. Yeah, no, can somebody tell me? I'm saying, yeah. Yeah.
Well, of course, the data set or the data frame is a data set of type T, okay? And then the RDD is a lower level, well, essentially a functional application or a functional structure from which you can write functional code against directly. So that's what I do.
Excellent, yes. So, long story short, just in case you couldn't hear him well, RDEs is basically the baseline of how Spark runs, okay? So every single query that we run, we actually generate RDDs, resilient distributed data sets. That's basically what it represents, okay? Now, data frames was this idea that we could control everything in terms of row-based operations, okay? And then later on, column-based operations with row-based structures, okay? Data set was to actually actually build type systems directly into it. So that way we actually have type followings. So data frames is commonly used by SQL and Python, which doesn't care about type, obviously, but data sets does. And so the context is that right now it's experimental because Scala is still running in the untyped form, okay? But that'll obviously get fixed. With Python, we didn't actually have to worry about all those things, so that's the reason why it's actually already working right now, okay? And so the one thing to call out is then, because of the fact that we're working with the dataset and data frame APIs, we're actually not supporting RDDs for Spark Connect initially. For the vast majority of you don't care what I just said, all right? Mainly because you don't want to run RDDs anymore, which is fair, okay? But just in case you want to do it, in fact, I'll demo it as well, then yeah, it just won't work. All right, so, right, okay, the Spark, that also translates to the fact that the Spark context is no longer available. So long story short, in the past when we were talking about Apache Spark 1.0 and 2x line, we actually had the availability of the Spark context. Now Spark 2, we introduced the concept of Spark session. The session basically was a combination of the Hive session, Spark context, and two other sessions, which I'm forgetting right now because they weren't heavily used. But the context basically is this, that the Spark context itself, the baseline context of how you run Spark, is no longer available. Why? Because it's an older concept and we don't actually use it in general anyways. So that is one of the things we removed from the get-go. Again, for vast majority of you, you're going to be okay with that statement, okay? And the client does not have direct access to the driver JVM, okay? So that separation is actually really important here. So the client will do its operations, the driver will do its operations. They are able to send protobuf to make the request, they can send arrow to get the information back, but they're not actually going to go and have direct access. It helps from a security standpoint, but also reduces, not removes now, reduces the likelihood of your one client taking out the driver. Now, it is still possible for you to take out the driver, okay? If you send a query, say that's the equivalent of select every single row, all 50 columns of 5 trillion rows, you're gonna kill the driver, okay? Doesn't matter. The driver will die because there's only so much memory a single driver can have on a computer to grab so much data. But if you're doing reasonable queries in the system, and we're still talking hundreds of millions or even billions of rows, that's actually fine. We can stream arrow the in-memory interchange from the driver to the client. It's chunked so that way it actually doesn't flood the driver, because most of the work is being done at the workers anyways, not actually at the driver level. Does that make sense, everybody? Cool, all right. All right, I already talked about the client applications IDE, so I'll skip that. But here, quick thing. Basically, this is the main difference in code, right here. Before we did val spark session.builder.get getter or create. Now you add the .remote. That's it. That's literally the difference in your queries. I'll show a part of that in the demo shortly. Some cases we go ahead and do the export. In fact, in my example, I'm not even going to bother with the exports, okay? But that's the context. So we've tried to make it as simple as possible, so whatever code that you wrote basically will work. You just have to toss in the .remote, so it's going to a remote system as opposed to going to your local system, okay? All right. And so, like I said, Spark 3.4 is already available. I'm going to hit the page itself. It's the standard programming guide, so you can start playing with it now. And then there's a notebook. Yeah, okay, cool. Let me just go into the demos because that's more fun, anyways. As I do this, any questions? No? Okay, cool. All right, so I'm gonna. Ooh. All right, so in here, actually, which directory is this? Okay, cool. So because we have the class path issues, let's see, can I, actually, give me a second. There we go. I actually have to run it, the Spark Connect Scala client from the connector repo, or the directory, excuse me, okay? So you can't run it from bin, which is where everything else in Spark is running from, or sbin. It actually has to run from there, so that way we avoid all the class path issues. That's the long story short, okay? But we run that, and then it goes ahead and builds. So since I'm not gonna make you watch the build, let me go ahead and start at least running part of the demo. All right, so first things first, I believe I already started the client. Let me, the Spark Connect server. So let me check here. Okay, yeah, still running. Okay, cool. Oh, no, all right, perfect. All right, so when I go ahead and just do a simple thing as spin Spark shell, that should connect to some instance of Spark, okay? So I'm gonna run that. Now, what happens here as it's running is that it'll actually try to bind to 4040, okay, on my local machine. This is all running locally first, okay? Because just in case this thing blew up, at least I had one demo working. All right, but what it's doing is connecting to a new instance of Spark, not the Spark Connect instance of Spark. Oops, sorry. So you'll notice it says here 4041, port 4041 versus port 4040, okay? So the Spark Connect server instance is running on 4040. This new instance is running on 4041, okay? So if I then go ahead and run a standard query, I'm just gonna go ahead and copy and paste it. That way you don't have to see me typing and all the errors I tend to make. All right, so perfect, that's a really simple query. It basically, I'm just doing a count, okay? When I go back to the client, the Spark UI, you'll notice 441 is showing me a standard count, okay? So far so good. Basically, everybody loves the Spark UI, right? Okay. That was a trick question. But you can see the DAGs, the visualizations, all the things to know how the queries are running. Yay, okay, cool. So nothing new yet. So you're all going to me, Denny, this is really boring. What's going on? Okay, so what's going on here instead though, if I was to go here, I think this is obvious enough that you're connecting to Spark Connect now, right? I don't know if you can tell. Okay, good, all right, so now we're connecting to Spark Connect. All right, so now I'm gonna run the same query, all right, on it. Now, this should result in an error. Okay, perfect. For anybody that's happened to be looking at the code or Spark, can you tell me why that code failed? Go for it. That's right, perfect. Somebody paid attention, yes! All right, so the Spark context is not available, which is what this SC dot. I purposely chose an older query to basically show this, okay? So in that query worked here because that's a Spark shell that's working in the monolithic driver, okay? So that's why this query worked. This query does not work because it actually cannot compile the Spark context. Remember, it's the thin client. So I actually have to run a proper RDD query. Okay, so let me go ahead and do this. Again, I'm just going to copy and paste it so that way you don't have to see me type it. All right, now this runs perfectly fine. Okay, and it gives you the same answer too, so no worries. If I go back to the UI, notice how when I ran it originally, it was simply showed count at console 24. Why is it? Because it's running from a local instance. All right, that's easy. That's the one when I was using the proper Spark context or Spark session. But with the Spark Connect, you notice that what it has here in the description, Spark Connect session ID, yada, 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 okay? So that's what's actually in the UI. So that's the difference now. It is the client that's sending protobuf, okay, to the Spark Connect server. Spark Connect server is then executing its queries just like it normally would. Same DAG visualization, scanning, whole stage code gen, and then returning the data. When it returns the data, it goes from the Spark Connect server and sends arrow back to the client. Okay, that's actually what's happening underneath the covers, all right? And let's see what else I want to call out. Yes, okay, so basically that was the key thing I wanted to call out. So basically that shows it. Now, what ends up happening is, like I said before, when you talk about out of memory errors, Now, obviously, this was a very, very small query, so that's not that big of a deal. But the point is, if I was to run a much, much bigger query, the likelihood, provided that I'm not trying to extract 5 trillion rows, the system will actually be able to handle it. That's the context. All right, so now, that seems fun, but you're going to say, Denny, this is all running on your local machine, okay? And you haven't shown me a squat about debuggability, all right? So let me go ahead and show that. But before I go ahead and do that, any questions before I switch to that demo? No? Okay, cool. All right. All right. You guys happier now? I've got a natural IDE now? Yeah, cool. All right. So now in this case, I am connecting to, sorry. Okay. All right. I'm actually connecting to a Databricks cluster, okay? I work for Databricks, what do you expect, okay? So it's gonna show me the Spark UI, and I've actually run a bunch of queries already, but what's going on here is that now I'm running this particular example, like also using Scala, right? Where I'm simply saying, hey, I'm gonna go ahead and initiate a Databricks session with a builder to remote. Now, literally, the only difference between a Spark session and a Databricks session is the Databricks session wraps around the Spark session and has authentication, authorization, basically when it comes to security. But that's it. There's very little difference between what the Spark session and what the Databricks session is. Okay, so now, just like I showed before, now we're doing a remote. Okay, so in other words, I'm not actually trying to configure it. In fact, I kept here. You can go ahead and take a picture, and none of it will work for you, okay? But basically, I'm basically telling, here's the host, here's the cluster ID, here's the token that I'm supposed to go connect to. All right, so now that I've got that, I'm gonna simply create the session, query this table. In this case, it's a samples.New York City taxi trips, the trips from New York City taxi dataset, and then I'm gonna go ahead and run. So in this case, it's just simply a data frame, limit 5, run. All right, so let's just go run that. Boom. All right. Okay. Don't worry about the wonderful legal reflectives. I told you there's a bunch of class path issues. So there's results. So far, so good. And if I go back to the UI, it'll take a small while to refresh. But the point is that same context. Now I'm running a query against my Databricks cluster, which is obviously not running on my laptop now. Okay? And of course, that's when the Spark UI is slow. All right, let's see what happens. Always during demo time, right? Yeah, so he's got a question. I need to answer that question right now. So.
I'm working with you here while it's still
Yeah, no, I appreciate it. No.
Yeah, so
this was planned.
So the illegal reflective stuff with Java 11, doesn't that become errors with Java 17? Because I think I tried and
yes.
it just doesn't work.
This is a great question. So long story short, I should have compiled this code on Java 8. Okay, that's why you're seeing the illegal reflections. I'm right now compiling with Java 11 because I'm actually trying to fix it for Java 11. Yeah, we're not on Java 17 yet. So we still need to go work on that, yes. Correct. So in other words, what he's saying is that can we go ahead and recompile this particular client to Java 17 while basically the Spark clusters are still using Java 8 or Java 11? The answer is yes, because what ends up happening, again, the Spark client and the driver, Spark Connect driver are two completely different systems now. Again, just to reiterate, protobuf in, arrow back out. So does not matter which versions you're talking about. There is no dependency between what your client is running on versus what your server is running on any longer. Okay, so because of that, yes, now you have to compile it, you have to go fix it. Like I said, you already see the illegal errors just from 11 on this demo. But the point is basically it's okay. It still works because it doesn't matter that the Spark Connect server, in this case on Databricks, is running on Java 8. Okay? Sorry.
Does that mean we can use Scala 3 on the client?
We have, great question. Can we use Scala 3 in the client? Yes. Presumably you can use Scala 3. I have not tested it, so I'm not gonna claim that it does work, but in terms of can you compile the code, yeah, you can compile the code. I just have not validated that it works yet.
In addition
I'm sorry?
Is this going to work for the community edition as well?
Oh, okay. So this example, you're talking about working on Databricks Community Edition. I don't believe this works on Databricks Community Edition yet. Okay, I don't want to use the word yet because we're going to be announcing something. Come to Data and AI Summit at the end of June. That will solve a lot of the problems related to Databricks Community Edition. So behind the scenes, long story short, Databricks Community Edition was this really cool thing that we built that allowed us to allow very cheap nodes, cheap instances that were spin up Docker instances so you can actually basically play with Databricks without actually paying for any money whatsoever, okay? So pretty cool, a lot of people like using it, but I'll be honest, we haven't maintained it very well for the last few years. Well, the reason why isn't because we don't like maintaining stuff, the reason why is because we have something new to talk about. That will make it easier, so that's the context, okay? All right, so what you'll notice here, again, same principle, is basically now, if you look at the UI, that query comes in as an execution plan against the Spark Connect Service gRPC, okay? So basically, now I'm actually, again, able to go ahead and have my, in this case, IntelliJ IDE go ahead and connect to my Databricks instance to run this query. You want to go ahead and use that, that's cool. You can also go ahead and, debug, right. I wanted to call that out, I forgot. Oh, the other thing I wanted to call out was Visual Studio Code. So with Visual Studio Code, we actually have an integration inside there. So that way, so whether it's IntelliJ or Visual Studio Code, you're actually good to go on either accounts. So let me go ahead and run that. So how many of you have run Spark code and thought to yourself, you love the error messages? Good. All right. That definitely was a trick question. So obviously, it's hard because you actually have, when you go to the UI itself, the query actually ran. But if I was to again say, go look at the driver logs and look at the standard, here's the standard output and error, here's the standard error. Everybody loves looking at this, right? Yeah, okay. So what you really want is to be able to debug exactly what the Spark context is, what the client is, what the configurations directly inside your IDE, yes? So with Spark Connect, so you asked me that question, Databricks Connect V1 was our initial attempt to solve this problem. V2, because we have the Spark client, we can do exactly that now. So inside your IDE, you can start debugging your code directly, okay? Obviously, we still have the driver logs and the standard error logs and everything else, but the point is that from the standpoint of you running the system, you're good to go now. You can just go ahead and do this. Okay, so hopefully that helps everybody on that front. Now, I actually have one more small little demo. Basically, the long story short here is this. With Spark Connect, now we can start doing experimental clients. So the one I'm showing you right now is the one on Go. All right, so this is a really simple query. All right, it is just this. And in case you guys care about looking at the code actually literally is sitting in the Spark-Connect Spark-Connect-Go repo. Oh, actually, sorry. Right. So basically, you can play with it right here. Okay, and so that is using. I'm going back to my local instance to show it, but basically. All right, here we go. But you can run this demo. It's obviously super fast because these are little quick demos. But the point is that now what I'm doing is I'm using Go to connect to my Spark Connect instance. Sorry. It's 949, 948, so here's the query right here. These two queries is actually the queries that were being used to go ahead and allow Go to connect to Spark Connect. So in other words, now I'm using a Go client, or I can do the same thing with Rust, I can do the same thing with Scala, I can do the same thing with other languages to basically create its own client to connect to Spark without actually utilizing all of the Spark monolith driver. Okay? Cool.
So does that mean there's a C binding so you can do that from Scala native?
There isn't. Okay, so the question.
You're gonna tell me C++ only, right?
Yeah. We're not against the idea of working with C bindings or for that matter, just go pure C++ for that matter. It's candidly, that's not the biggest ask. Right now, the biggest ask for us, and that's why we built these experimental clients. The two biggest ones outside of Python were Go and Rust. Those were the two biggest ones, so that's why we started building those first. So, but if you guys want to continue on, you're more than welcome to ping us. Obviously, the Scala one we baked in right from the get-go. So. Okay, so the question is Rust basically completely unrelated to the protocol? Yes, you can. We don't have it in GitHub yet. I think we're going to have it. I want to say probably exactly the same time as we have Data and AI Summit. That's when we'll have it, which is at the end of the month. We're going to have basically the Rust client that actually now connects to Spark Connect. Again, it's a client. So what is it doing? It's simply a thin client that is using Rust crates to send protobuf. Spark driver, Connect server does its thing, sends Arrow right back to Rust. Rust and Arrow are basically friends at this point now, so they're buddies. So yeah, it's a very easy thing to build, basically. Yeah. Cool. Question over there. Or sorry, there. Yes.
Yeah, this will be quick. Following up from the... Whoa, some feedback. I'm going to move about 10 feet.
Oh, the speaker, yeah.
Yeah, okay. Following up from the Scala native question, is there anything specific architecturally or dependency-wise about the Scala thin client portion of it that couldn't itself be compiled to other Scala platforms?
Oh, no. Great question. There isn't. We designed this to be very much from an open source perspective. So in other words, if you're using Scala platforms and you say, hey, now I want to take this and chuck it into Kotlin, or take this and chuck it into, I don't know, Trino. No, there really isn't. I mean, obviously you don't want to use Kotlin and Trino, but you understand what I'm trying to get at. Like, you have a Scala platform. There's nothing in our protocol that's preventing you from doing that. Now, I'm not going to pretend everything builds right from the get-go, but the whole design of this infrastructure was to give you the maximum flexibility.
Okay, so like hypothetically, Scala JS support when?
Want to do a PR?
Maybe.
Yeah, but no, he's not wrong. In all seriousness, the reason we actually have the Go and Rust clients, by the way, is because actually the community did. When we announced the creation of Spark Connect, we basically went ahead and went out to the Spark community and asked, which clients did you want to do first? We obviously have the Python one, we obviously have the Scala one. Which are the ones you actually want? And what we got back wasn't just votes for Go and Rust, we actually got contributions for Go and Rust. So that's why we started with those first. So if you want to do, for example, Scala.js or anything else, yeah, like, first of all, create an issue so at least people will vote against it and say, yes, we all would love to do it. And even better, if you want to create a PR, we're definitely up for it. Seriously, I was literally fixing the Go client 2 days ago. Okay, so I was preparing for this demo. I'm like, oh, it actually doesn't work. So I was going like, oh, this is going to suck for us. So I literally fixed it. Perfect. Same concept. Go and do a PR. We'd love to see it. Okay. Cool. Any other questions? Oh, sorry.
Yeah. So what's the deal with like UDFs? So obviously I can run the code in Spark Connect, and normally I'm running jobs, so I I can access them from the class path directly. What's the pattern here when I want to do something a little more? Okay,
so the pattern for UDFs is that the UDFs have to be available to, this is where the context switch is going to need to happen, right? The UDFs need to be installed on the server now, right? And you don't install them from the client. We're not going to let you go from the client and send in a UDF, at least until we figure out the security context behind somehow being able to do that safe. So right now the UDFs have to be installed already on the server. Once they're on the server, they're completely accessible through Scala, Python, PySpark, whatever else. But we would actually require you to install those UDFs directly on the server first.
So I start the server with a jar attached with my UDF.
Yeah, that's it. Literally, you put back to the good old-fashioned class path, start the server, make sure the UDFs and the classes are all, and the jars are all in the right location, and you're good to go. Because don't forget, when we submit the jars, right, we're not just submitting it in that single driver, we're going to submit it to every single one of the workers. Yep. So that's why I'm saying you actually have to pre-install. It is unsafe for us to try to submit it from a thin client. extremely unsafe. So
Makes
that's
sense.
why we're not even, like I said, we are looking at the possibility of doing it, but we still have not figured out how to do this safe. So let's not even start doing that yet. So yeah.
So on the vein of what you were just talking about, can you just still use Spark Submit for the regular to get the cluster going and get the client going, but then you could connect with the Spark Connect client as well?
Yes. So when you run the Spark Connect server, it itself is basically, long story short, instantiating a service that's on port 15002. Okay. Versus the regular service, which is when you start master, it's on 7077, and then the connectivity of the UI is 8080, and then the jobs itself 4040 and 441, and yada, yada, yada. Long story short, yes, you can run both the Spark Connect server instance and as well as the regular Spark instances on the exact same driver, on the exact same cluster. Okay? There's no problem for you doing that. The key difference is how your client now connects to it. When you do a Spark Submit, the assumption is that you are submitting directly to, submitting directly to the driver, that you have direct access to the driver, and you also are doing it synchronously. In other words, you're going to send it, and you're going to wait, and you're going to wait, and you're going to wait for the results to come back. Okay? In the case of Spark Client, now these demos don't show this, but this is an important aspect. With the Spark Connect, the client makes a submission. It can be done asynchronously now. So you can make the submission. You don't have to wait. You can disconnect, and provided you have the ID of the submission, you can reconnect to the Spark Connect server at a completely later date, and you can go ahead and actually request for the information back. Now, the only problem with this is that if you wait 5 days, we probably would have basically expunged it from memory. Okay, so it's not meant to be something where you're holding, where I want to have a driver that basically itself is 2 terabytes so I can hold everything in memory. But the context is that for lighter, thinner clients that you don't want it just to spin, now you have the ability to do that. Cool. All right. Any other questions? Go for it. Oh, yeah.
It's been a while since I've used Spark, but so I don't know if things have changed. But I remember, like, I guess on the user-defined function question, I remember it having to, both serialize the distribute the jar to all the workers in the cluster, and also serialize your closures across the cluster. And I guess I'm curious how, like, with the dataset API, that'll work over this client, or.
Oh, sorry. Could you repeat? I'm probably missing the context. I'm sorry.
My understanding of the dataset API in my past experience was that the jar needed to be distributed to the cluster members, and also there were closures being serialized across the cluster.
Correct.
And so I'm wondering how that would work across this thin client.
That great question. Sorry, now that I understand the context, that all stays the same with dataset APIs. But don't forget, it's the server that does that submission of the class of the jars. It's not the client. The client all the client's doing is making the request. The server itself is the one that says, okay, based on this request, I'm going to have to serialize, deserialize. I'm going to have to send these jars. I'm going to actually have to open up these classes, access these classes, excuse me. That's actually what's going on. So from the standpoint of the Spark server itself, nothing's really changed. Okay, so how you would normally do a PySpark, a Scala shell, a Spark Submit, they all stay exactly the same. The main difference is just the fact that now when you're instantiating from a thin client, it's simply, you're able to tell that, and so you're separating what the server's doing from what the client's doing now. That's the main difference. There are obviously restrictions because of it, right? For example, like the dataset API right now is untyped. We're primarily using the data frame API. But outside of things like that, everything else pretty much operates the same. We're basically making the assumption that you're on Spark 3x or later to do that. Right. Cool. Good with questions? All right. Well then, actually we just finished right on time, so this is perfect. Sweet. Well, thanks very much, everybody.